Hello everyone. So if you remember from the last video or a couple videos back, we have learned differentiation rules for sums and differences of functions. So functions like f of x plus g of x, plus or minus, since it also works for subtraction, and functions with a constant multiplied in front of it. And that's about it. I specifically mentioned that you can't, the derivative of this is not equal to derivative of this times the derivative of that. In fact, in this video, we're going to learn the proper way to take the derivative of products. And that is called the product rule. The product rule. And it says, if you have two differentiable functions, f of x and g of x, that means the derivative of f of x, g of x, so f of x times g of x will equal f prime of x times g of x, so the derivative of the first function times the second function plus the first function, normally, times the derivative of the second function, or f prime g plus fg prime, or g prime f. Okay, so this over here is the product rule. So again, you can prove this using the limit definition. I might do that in another video. Okay, so we're going to apply this to a function. Okay, to an actual function. Let's try to find a derivative. F of x equals 3x minus 1 times 2x plus 3. Now, there are really two ways to go about this. So A, which is most obvious, you can use the product rule. You have the product of two functions. So let's do that. Okay, so f prime of x, or the derivative of f, will be the derivative of the first function. So that'll just be 3 times the second function. Okay, this is function 1, function 2. Okay, so derivative of the first times the second function plus the derivative of the second function, which is 2 times the first function. And that all, if you add it all up, will be 6x plus 9 plus 6x minus 2, or 12x plus 7. Okay. So the second way to do this is to simply expand this all out. Okay? So this is number 1. Number 2. Okay? F of x. So I'm just going to rewrite this function. And we're going to expand this out. So we get 6x squared plus 9x, FOIL it out. First, outer, inner, last. Okay, so we get 6x squared plus 7x minus 3. And we take the derivative of that. Well, you just use the power rule. Okay, so first, the derivative of the first term will be 12x plus 7, which is the exact same thing we got using method 1. So either way can work for something like this. Personally, I like the product rule for this better because you only deal with linear terms. Here you got to expand it out a little bit. But either way is fine. Where either way is not fine would be in a function like this. F of x equals x times cosine of x. X times cosine of x. So you can't really multiply it out since cosine of x is not an actual polynomial function. So you have to use the product rule for this one. Okay? So what we're going to do is use the product rule. F prime of x equals the derivative of the first function times the second function. So that's 1 times cosine of x, or just cosine of x, plus the derivative of the second function, negative sine of x, times x, where we get cosine of x minus x sine of x, minus x sine of x. Now, what if I asked you to find the tangent line at pi over 6 and root 3 pi over 12? Okay. Now you just plug pi over 6 in to the equation. Cosine of pi over 6 minus pi over 6 times the sine of pi over 6. So cosine of pi over 6 is root 3 over 2. Root 3 over 2 minus pi over 6 times 1/2. Sine of pi over 6 is 1/2. Okay, so that'll give you pi over 12. So that'll give you pi over 12. So if we were to combine these, you get 6 root 3 minus pi over 12. Over 12. Hope I did that right. It looks like I did. Okay? So let's put this in slope intercept. Let's do point slope for this one. So y minus y1 equals m times x minus x1. And we're gonna try to, so it's a lot of simplification here, but and we get over here. Minus pi times 6 root 3 minus pi over 12. Well, sorry, over 72. 12 times 6 is 72. And let's just bring the left term to the right. And we get y. So this will be 6 root 3 pi over 72, which will get us, we could distribute this, pi squared, which will get us y equals 6 root 3 minus pi over 12x minus 12 root 3 pi minus pi squared over 72. And we are done. Oh wait, never mind. We are not done. Okay, because I just realized I made an algebra mistake. So I'm adding this to a negative quantity. So this should actually be 0. No, 12 root 3 pi. Okay, so I think I just caught it. So the actual equation is 6 root 3 minus pi over 12x. Negative cancels negative, plus pi squared over 72. So that should be the correct equation. Okay, so fortunately I just realized that algebra mistake. So this is the real equation. So yes, this is a negative quantity. You add it, which means this should actually be 0 rather than this. So now we are actually done.